This is my prediction of the NECO 2026 qualitative analysis. What you are expected to see on the exam day. On the exam day, you will be analyzing sample C. Sample C is a blue salt known as copper-2 tetraoxosulfate 6. And the first question you will see is that you should dissolve sample C in distilled water. So, under test, you write C plus distilled water. And because it's a blue salt, once you dissolve it in water, you will get a blue solution. So, under observation, you write C dissolves to form blue solution. And from this observation, you will see that the inference is clear that C is a soluble salt. And that is even the essence of this test. Once you dissolve something in water, you are expecting it to either dissolve or not dissolve or partly dissolve. Now that it dissolved to form a blue solution, it means C is a soluble salt. Now, after this, they could ask you to divide this solution into two. You divide into two because you are expected to test for presence of copper-2 ion and presence of tetraoxosulfate 6 ion. So when you divide into two, they will ask you to add a reagent, ammonia solution, in order to test for copper-2 ion. So you write first portion plus ammonia. They will ask you to add it in drop and then in excess. So you write first portion plus ammonia in drops, comma. Then you go to the next line and write then in excess. So when you add ammonia in drops, what you are expected to see is light blue gelatinous precipitate. It is a light blue precipitate and also gelatinous. It is like a gel which dissolves in excess to form deep blue solution. If you pour the ammonia in excess, that gelatinous precipitate will dissolve to form a very deep blue solution. This is as a result of formation of complex between ammonia as ligand and the copper-2 ion. So the light blue precipitate infers that copper-2 ion is present. The deep blue solution confirms presence of copper-2 ion. Now we have succeeded in testing for the presence of copper-2 ion. The next is to test for presence of tetraoxosulfate 6 ion. They will ask you to add a reagent, barium chloride. Immediately when you add barium chloride, you will see a white precipitate. And then they will ask you to add hydrochloric acid. They want to use the hydrochloric acid to try to dissolve the white precipitate. So when you add barium chloride, the sulfate ion will attack barium chloride and you have barium sulfate, which appears as white precipitate. But it is not only sulfate that shows up as white precipitate when it attacks barium chloride. Carbonate and sulfites also show up as white precipitates. So when you add barium chloride, you see white precipitates, right? You first of all suspect carbonate, sulfite, and sulfate because these three ions show white precipitate when they react with barium chloride. Now, adding hydrochloric acid is a way of differentiating which one is actually present. When you add hydrochloric acid, if it is carbonate, this carbonate ion will attack hydrochloric acid to yield carbon 4 oxide. So you will experience effervescence. If it is sulfite, the sulfite will dissolve in hydrochloric acid. So the white precipitate will dissolve. If it is sulfate, the sulfate will not react with hydrochloric acid. So the white precipitate will remain. Now, when you add HCl in drops, then in excess, the white precipitate will remain. So you write white precipitate which remains insoluble in excess HCl. Because it remained, you now single sulfate out and say that sulfate or tetraoxosulfate 6 ion confirmed. If you are new to this channel, subscribe and please try to recommend our channel. Bye.